Before we begin, take a moment to slow down. Relax your shoulders. Unclench your jaw. Let your breathing become natural. There's nothing you need to do right now. Nowhere you need to rush. Just listen. This is a story about the future. About intelligence and about a question humanity is only beginning to understand. So sit back, focus, and let's begin. The silence of the universe. The Fermi Paradox and the question, where is everybody? If there are billions of stars, why have we still spoken to no one? Part 1 of the night sky that should have been loud. There are some questions so large that humanity does not really answer them. It only circles them. It builds telescopes. It writes equations. It sends probes into the dark. It listens through static. It stares upward until silence itself begins to feel like an accusation. The Fermi Paradox is one of those questions. It begins with a contradiction so simple that it almost feels unfair. On one side, modern astronomy tells us the cosmos is full of worlds. NASA has now confirmed more than 6,000 exoplanets, and its broader estimate is that the Milky Way likely holds trillions of planets. On the other side, astrobiology still has a brutal answer to the question of life beyond Earth. No life beyond Earth has ever been found, and there is no scientifically confirmed evidence that extraterrestrial life has ever visited our planet. The universe keeps getting bigger, more crowded, more statistically promising, and still, it says nothing back. That is what gives this mystery its emotional weight. If the universe were empty, silence would not be strange. If planets were rare, silence would not be strange. If Earth were obviously unique, silence would not be strange. But the stars are not rare. Planets are not rare. Habitability no longer feels like a fantasy category pulled from fiction. NASA's exoplanet work has shown that planets are common, that many are roughly Earth-sized, and that some orbit in habitable zones where liquid water could exist under the right conditions. The search is still young, but it is no longer wandering blindly through pure speculation. We now know enough to make the silence more uncomfortable than it used to be, and into that discomfort steps one of the most famous remarks in modern science. In 1950, during a lunchtime conversation, physicist Enrico Fermi is said to have cut through the optimism around extraterrestrial civilizations with one devastating question: where is everybody? SETI's summary of the paradox explains why that question hits so hard. If intelligent civilizations are common, and if even some of them develop modest interstellar capabilities, then the galaxy should have had more than enough time to be crossed, colonized, or at least visibly marked. The Milky Way is vastly older than any plausible wave of expansion would need to spread across it. So if the galaxy should be old enough for intelligence to have arrived almost anywhere, why don't we see the footprints? Imagine the emotional shape of that realization. Not a scientist peering through a telescope and seeing a hostile fleet. Not a dramatic signal from the stars. Just a lunch table. Conversation. The mind moving one step ahead of everybody else in the room. If there are many civilizations, some should have spread. If some have spread, the galaxy should not look untouched. If the galaxy looks untouched, then something in our assumptions is wrong. That is the paradox. It is not proof that we are alone. It is proof that the numbers and the silence do not sit comfortably together. A decade later, Frank Drake gave that discomfort mathematical form. In 1961, the Drake equation laid out a framework for estimating how many communicative civilizations might exist in the Milky Way by multiplying together factors like star formation, the fraction of stars with planets, the number of potentially habitable worlds, the fraction on which life begins, the fraction on which intelligence appears, the fraction that develops detectable technology, and the length of time such civilizations remain detectable. Even today, some of those factors are becoming less mysterious thanks to astronomy, while the biological and civilizational terms remain deeply uncertain. That uncertainty is exactly why the paradox still breathes. The equation can make the galaxy look crowded or almost empty depending on which unknowns you choose. There is something eerie about that. The question of whether we are alone may not hinge on one grand truth. It may hinge on tiny fractions hidden inside biology, culture, time, and catastrophe. Maybe life begins almost everywhere. Maybe it almost never does. Maybe intelligence is common. Maybe it is a freak accident. Maybe civilizations light up the sky for millions of years. Maybe they go quiet after a few centuries. Every answer changes the emotional meaning of the stars. And yet Fermi's challenge remains hard to escape, because even very conservative assumptions can still make the galaxy feel older and more available than the silence suggests. Britannica's summary of the paradox notes that if aliens could travel at only 1% of the speed of light, the Milky Way could in principle have been colonized many times over within its history. SETI's explanation makes the same point in even blunter language. Whether interstellar expansion is slower or faster, any halfway reasonable colonization timescale is still tiny compared with the age of the galaxy. The paradox does not require faster than light magic. It only requires time, and the universe has had a lot of that. This is where the story becomes cinematic, because now the night sky is no longer just beautiful. It becomes suspicious. Every star might have had enough time. Every ancient planetary system might have had enough time. Whole civilizations could have risen, expanded, collapsed, and vanished long before human beings learned to strike metal or write laws. If that is true, then we are not merely asking why nobody has spoken. We are asking why the galaxy does not look used. Why no unmistakable engineering scars? Why no obvious probes? Why no undeniable beacons? Why no empire ruins in the sky? Why no machine-made glare around distant suns? Why no voice that every radio dish on Earth has to admit is not natural? And still nothing confirmed. NASA's astrobiology and exoplanet programs are very direct about where things stand. We are the first generation that knows planets around other stars are common, yet so far the only life we know is here or on Earth. SETI makes a similar caution from the technosignature side. The lack of detected signals does not necessarily mean there are no extraterrestrials, because our search still suffers from limited sky coverage, insufficient sensitivity, and the possibility that we are listening on the wrong frequencies or for the wrong kinds of signatures. In other words, the silence may be real or it may simply be larger than our instruments. That caveat matters, because the Fermi Paradox is powerful, but it is not the same as a solved case. SETI itself warns that the paradox is a vast extrapolation from a very local observation. Looking around and seeing no aliens is not quite the same thing as proving there are no aliens, just as failing to see a bear outside your window does not prove bears do not exist. The argument is strong because of time and scale, but it still rests on assumptions about what advanced civilizations would do, how visible they would be, and whether our methods are good enough to find them. And that is where the silence becomes even more interesting, because there are really two mysteries here, not one. The first mystery is astrophysical. How common are life and intelligence? The second is behavioral. If intelligence exists, how does it behave? Maybe the universe is quiet because life is rare. Or maybe it is quiet because intelligence is cautious. Or because technology is brief. Or because civilizations don't colonize the way empire-minded humans assumed they would. Or because the galaxy is full of life that has no interest in shouting. Even within SETI, this is taken seriously. The Institute's public primer says the Great Silence has many speculative explanations, ranging from sociological ideas that perhaps civilizations are uninterested, isolationist, or cautious, to the simpler possibility that we have just not looked hard enough. That is why modern SETI is not only listening for the old science fiction version of aliens blasting radio greetings into space, it is expanding into broader searches for technosignatures and indirect traces of technology. And now the paradox begins to darken, because once you stop imagining extraterrestrials as friendly radio hosts waiting to say hello, the silence stops feeling like disappointment and starts feeling like warning. What if the universe is full, but hidden? What if intelligence tends to become less visible as it becomes more advanced? What if our basic assumption of that powerful civilization should be noisy, expansive, and obvious is just a projection of our own historical instincts? A 2025 SETI discussion of future technospheres pushed exactly that possibility. It described scenarios in which a technologically advanced civilization might, from a distance, look almost biologically ordinary, perhaps even like a pre-agricultural world, while most of its technology exists elsewhere in the system or in forms that do not create obvious atmospheric or energy signatures. In some of those models, a civilization could be advanced and still remain largely invisible to the telescopes we currently use. That possibility does not solve the paradox, but it weakens one of its most intuitive assumptions. That advanced life must be flamboyant enough for us to spot from afar, which means that the silence may not be one silence. It may be several. The silence of worlds where life never began. The silence of worlds where life stayed microbial. The silence of civilizations that died young. The silence of civilizations we are not equipped to detect. The silence of systems where technology moved away from the planet and left the atmosphere looking natural. The silence of minds that have no reason to call out into the dark. And then there is the oldest, most disturbing possibility of all. Maybe the silence is simply honest. Maybe there is no one. NASA's own framing of the search for life captures the emotional tension perfectly. There are plenty of planets, and the science keeps growing more hopeful, but so far we still have no evidence of life beyond Earth. Stars now look fertile enough to make us hopeful, but the evidence has not followed. We stand in a universe that appears increasingly capable of producing life, and yet we still possess exactly one confirmed example. That is what makes the Fermi Paradox more than an astronomy question. It is a mirror. If the universe is full and silent, then intelligence may not behave the way we dream it does. If the universe is empty, then life on Earth may be unimaginably precious. If the truth is in between, then we may be early, late, deaf, naive, or all of these at once. By the end of part 1, nothing has been solved. The stars are still there. The planets are still there. The mathematics still tempts us toward company. The evidence still leaves us alone. And above all, the question still hangs over the night exactly as it did when Fermi asked it. If the galaxy has had so much time, and if worlds are so numerous, and if intelligence is even moderately possible, why does the universe still sound like an empty room? Part 2, the great silence, the hidden civilizations, and the possibility that we are really the most unsettling answers to the Fermi Paradox are not the dramatic ones. Not alien invasions. Not giant ships hiding behind the moon. Not secret governments suppressing cosmic contact. The most unsettling answers are quieter, because they fit too well. They feel like truths the universe might actually choose. One possibility is that life itself is rare, not impossible, not mystical, just unbelievably hard to start. Britannica's summary of the paradox notes that one route through the Drake equation is simply to drive down the fraction of habitable planets on which life actually begins. Life on Earth seems to have appeared relatively early in our planet's history, but from a sample size of 1. We do not know whether that means life is easy or whether we are staring at a freak statistical success and mistaking it for a rule. If biology almost never crosses the threshold from chemistry into self-replication, then the galaxy can be full of planets and still be mostly dead. That idea is frightening because it makes Earth less ordinary, not more. It suggests that oceans, atmospheres, energy sources, and habitable zones are still not enough. That something deeper, stranger, and far less probable had to happen here. That what feels natural to us, the cells, metabolism, evolution, may in fact be one of the rarest events in the universe. And if life is not the bottleneck, then intelligence may be. Britannica's breakdown of the Drake logic points out how late technological civilization appears even in Earth's own timeline. Homo as a genus is very recent compared with Earth's age. Tool-making is young. Radio technology is only a little more than a century old. From that perspective, intelligent, detectable civilization looks less like the natural endpoint of evolution and more like a brief flash at the end of a very long biological chain. If intelligence is an improbable accident rather than a common destination, then the silence may simply be the sound of most biospheres never producing anyone who can build a telescope. And if intelligence is common, the next filter may be civilization itself. This is where the paradox becomes almost moral. The great filter, a term Britannica links to Robin Hanson, is the idea that somewhere between habitable worlds and galaxy-spanning civilizations, there is a step so improbable or so lethal that very few ever make it through. That filter could lie in the origin of life, the rise of complex cells, the emergence of intelligence, or most hauntingly, the survival of technological civilization after it gains enough power to destroy itself. Nuclear war, ecological collapse, runaway technology, engineered pandemics, machine misalignment, resource exhaustion. Once a species becomes clever enough to reshape a planet, it may also become clever enough to erase its own future. This explanation terrifies people for a reason, because it does not just explain the sky, it judges us. If the great filter is behind us, then we are miraculous. If it is ahead of us, then the silence above may be the graveyard of civilizations that reached our stage and failed. That would mean the stars are not empty. They are full of unfinished stories. But the paradox does not only point toward death. It may point toward invisibility. SETI's public materials emphasize that we have searched only a tiny fraction of the possible search space for technosignatures. Limited sky coverage, finite sensitivity, and the chance that we are listening for the wrong kinds of signals all mean that silence today does not equal silence forever. Modern SETI is increasingly explicit about this. Failing to hear something may reflect limitations of method rather than a lack of neighbours. Our radio searches, optical surveys, and atmospheric studies are still early, narrow, and biased toward the kinds of civilizations we already know how to imagine, and perhaps imagination is the real bottleneck. Humans assume advanced civilization should be noisy because human civilization has been noisy. We assume expansion because our history has been expansionist. We assume visible megastructures because our own technological myths reward scale. We assume communication because we romanticize the act of contact itself. But SETI researchers have recently been pushing back on that assumption. The 2025 discussion of Earth's future technosphere described plausible scenarios in which a civilization might remain technologically advanced while producing little or no obvious planetary technosignature. In some of those futures, a distant observer might see atmospheric signs of biology but no detectable technology at all, even though a sophisticated civilization exists elsewhere in the system or in less conspicuous forms. If that is possible for us, then the same may be true elsewhere. The galaxy could be inhabited by societies that are real, advanced, and still mostly hidden from the methods we currently rely on. That shifts the emotional flavour of the paradox completely. Maybe the universe is not empty. Maybe it is subtle. Maybe the loud civilizations burn out. Maybe the mature ones become efficient, distributed, or quiet. Maybe the Kardashev dream of ever-growing, star-devouring empires is just one path among many, and perhaps not the dominant one. SETI's recent framing explicitly challenges the old assumption that civilizations must grow into ever larger, ever more energy-hungry structures. Some future scenarios they discuss stabilize, collapse, oscillate, or remain technologically active without becoming overwhelmingly detectable. If advanced intelligence can survive by becoming less visible rather than more visible, then the Great Silence may not be a contradiction at all. It may be a selection effect. We are looking for fireworks in a universe that may prefer whispers. Another possibility is even stranger. Maybe the overlap in time is too small. The universe is old, but civilizations may be brief. The Drake equation includes one term that quietly governs almost everything, L, the length of time a civilization remains detectable. If radio bright, technologically obvious phases last only a few hundred or few thousand years, then even a galaxy that produces many civilizations over billions of years might still contain very few that overlap with us right now. Civilizations may bloom and disappear like sparks in a storm, numerous in total, but rarely simultaneous, rarely close enough in time to converse. That idea is almost poetic in its cruelty. Not alone in principle, just alone at the moment. Imagine entire cosmic histories that miss one another by a million years. A civilization rises around one star, sings into the dark, disappears. Long after its ruins cool, another civilization wakes somewhere else and asks the same question into a quiet galaxy. No one is there to answer, not because no one ever lived, but because the intervals do not overlap. And then there is the old as you style possibility, not the strongest scientific favourite, but persistent because it touches something deep in us. SETI's own Fermi overview lists sociological explanations that can sound contrived but refuse to die completely. Perhaps many civilizations find colonization too costly. Perhaps many choose isolation. Perhaps we are intentionally ignored, studied, or left alone. SETI does not endorse one of these as a solution, but it does acknowledge that the spectrum of explanations ranges far beyond pure physics. Intelligent life, if it exists, may make choices, and choices are harder to model than stars. Still, the most grounded explanation may be the least dramatic. We are early. NASA describes the search for life as just getting started. We are living at the beginning of serious exoplanet science, not the end of it. We have only recently reached 6,000 confirmed exoplanets. We have not yet found life anywhere else. Our instruments are improving, but much of the search remains in its infancy. JWST and future observatories are only beginning to test atmospheres of potentially habitable worlds. SETI's methods are broadening, but the search space is still vast beyond comprehension. It may be that humanity has asked Fermi's question at the cosmic equivalent of dawn far too early to conclude much from the silence. This answer is comforting and unsettling at the same time. Comforting because it leaves hope intact. Unsettling because it reminds us how little we have actually done. We like to speak of the search for extraterrestrial life as though it has already been exhaustive. In truth, it has barely begun. We have not searched every wavelength. We have not watched every star long enough. We have not resolved every exoplanet atmosphere clearly enough. We have not explored every ocean moon in our own system. We have not even answered the simpler question of whether life has ever existed independently anywhere else nearby. NASA's Astrobiology pages are blunt on this point. No life beyond Earth has yet been found, but the scientific basis for expecting extraterrestrial biology has grown stronger as we learn more about extreme life on Earth, the chemistry of the cosmos, and potentially habitable environments on Mars, Europa, Titan, and distant planets. Hope is growing not because we already know the answer, but because the problem is finally becoming experimentally serious. And that leaves us in the most human position of all, between probability and loneliness. The stars suggest possibility. The evidence insists on caution. The silence invites philosophy. The science demands patience. Maybe the Fermi Paradox will dissolve as our instruments improve. One day we may find biosignatures in an exoplanet atmosphere, chemical disequilibria too suggestive to ignore, or a technosignature so narrow and unnatural that debate collapses overnight. SETI notes that a confirmed technosignature would likely be subtle, but unmistakable, perhaps a narrowband radio signal or laser pulse that nature simply does not make. Until then, the paradox remains suspended between what seems statistically plausible and what we have actually observed. But perhaps the deepest power of the paradox is not scientific at all. It is existential, because every serious answer changes what it means to be human. If life is rare, then Earth is sacred in a way we have barely earned. If intelligence is rare, then consciousness may be one of the universe's strangest accidents. If civilizations usually destroy themselves, then the sky is a warning. If advanced societies go quiet, then maturity may look like restraint rather than empire. If we have simply not looked hard enough, then our loneliness may be temporary. And if we are truly alone, then there may be no higher witness to history than us. That last possibility is almost unbearable. Not because it is empty, because it would make responsibility enormous. A silent universe would not make humanity small. It would make humanity precious. So when people ask, where are they, there may never be one perfect answer. The paradox may resolve not through a single revelation, but through many partial truths. Life may be common, but intelligence rare. Intelligence may be common, but detectability brief. Detectability may be brief, but our search is shallow. Civilizations may exist but remain quiet, distributed, or hard to see. The silence may not come from one cause. It may come from a stack of filters, behaviors, and blind spots layered on top of one another. And that is why the Fermi Paradox still feels so cinematic, because it is not just a scientific puzzle. It is a cosmic suspense scene stretched across the entire sky. Billions of stars, trillions of planets, a galaxy old enough for impossible things to have happened many times over, and still no confirmed voice. Maybe the answer is coming. Maybe the silence is the answer. Maybe the universe is full of life that never learned to shout. Maybe it is full of ruins. Maybe it is full of hidden neighbors. Maybe it has been waiting for us to learn how to listen properly. Until then, the stars hold their breath, and we keep asking the same ancient, unbearable question into the dark. If the universe had so much time to become crowded, why does it still feel so alone?